easy ones. So this one's pretty easy right here. FeCl3. FeCl3. Actually, no, never mind. Okay, so this is the first introduction to the ones that are not so easy. So this is iron right here. Fe. That's iron. And you're going to want to say that this is called iron chloride, because this is iron, this is chlorine, cut off the end, you say chloride. But it is not iron chloride, because these right here, these things in the middle, these that don't have a charge, they're called the transition metals. They come in a bunch of groups. So iron is actually not one thing. Think of iron like a last name. Like my name is Aaron McCon, right? There are a bunch of different McCons. There are a bunch of different irons. You have Fe+1, this is the first brother. You have Fe+2, that's the second brother. Fe+3, that's the third brother. Fe+4, the fourth brother. There's a bunch of different versions of iron, or a bunch of different brothers with the same last name. So if I say iron chloride, I say iron chloride. It's like telling my neighbor to go get that McCon kid. My last name is McCon, right? I'm Aaron McCon. So they say, go get that McCon kid. They're like, which one? There's like 4. And you're like, I don't know, you gotta give me more information. Like, I don't know. So I say iron chloride. I say, which iron? And so you have to tell me. In this case, chlorine is 3. So you got 3 negative charges here. Cl3. So this Fe, when you like swapped and dropped, the number on the Fe, whatever this was, you swap and drop, that number goes down here. That was a 3. So the particular version of iron I'm dealing with is iron 3, that one. This is called iron 1, iron 2, iron 3. It's the names. So instead of saying iron chloride, I say iron 3 chloride in Roman numerals. So iron 3 chloride. Just to recap, if it is in this weird block, this transition metal block, that means that these atoms don't come alone. Like for one of these, this is lithium, right? There's only one version of lithium. So if I say, who do I know who has one person? I don't know. If I say, go get that Keller kid, they're going to know who that is because there's only one kid with the last name Keller, right? But if they say, go get that McCon kid, there are 4 different McCons. So I actually do have 3 brothers. There are 4 of us. So they're not going to know who you're talking about. You can give me more information, right? So these in the middle, these are all parts of very big families. And you cannot know, just from the name, which version is going to show up, which family member. You need more information. So everything in the middle, you got to put a number 2. Iron 3 to let you know, oh, which iron? That one right there, that iron. Anyway. Next we have the polyatomic one. So now it's like this, Na2SO4. Na2 is pretty straightforward. It's just sodium, so you're going to start it with sodium. But SO4, I don't see it up here. And I have not been taught how to deal with something that has like 6 parts. I'm going to do NaSO4, that's like 3 atoms. But the realization is that this right here, SO4, is actually one polyatomic atom. It's like one person that has like 6 heads, right? It has 1 sulfur, 4 oxygens. It's like a person with 4 heads. So this is sodium. And you have to look up all the polyatomic ions every single time. So you look it up on your chart. And you see that SO4 is called sulfate. So sodium sulfate. So Na2SO4. Great. Now this one is very similar. NaC2H3O2. This looks real spooky, right? Because this is a lot of stuff. But Na is sodium. And this ridiculous thing that you see on the back is called acetate. ACETATE. It's the very top of your chart, but if you're Googling it online, just Google this part. And you'll get it. Acetate. Sodium acetate. Great. I'll put the formula in too, and then I'll move on to the bottom. So. Also, real quick before we move on, actually, I want you to notice something. So I wrote these in red sometimes. Calcium sulfide, magnesium oxide, iron chloride. The IDE at the end lets you know that it is a normal element. But some of these are very deceptive. Look at this. Sulfate. 8 looks a lot like ide. Sulfate, it seems a lot like it might just be this. But it is not. You need to have that IDE on the end to be a regular ion on this side. To be a regular anion, you need to have that IDE. Anything else is not going to be regular. It's going to be a polyatomic weirdo that you have to look up. So don't be confused just because this and this are very similar. The IDE on the end lets you know that it's a real atom. So now, down here, strontium chloride. Well, okay, sorry, I had to bring it on the table. The way that you do these is you do swap and drop with the charges. Or you can just think about how you get it to neutral. That also works. So strontium chloride. This is strontium. Strontium is going to make a +2 ion, so Sr +2. Chloride is right here. It's chlorine. The IDE lets you know that it's -1, so Cl -1. You could just think about this. You could say, well, how many chlorines do I need? How many negatives do I need to cancel out this strontium? And I need 2, right? Because +2, that's the strontium, -1, that's 1 chlorine, -1 is another chlorine, that's 0. You can think about it in terms of charges, in which case you would get SrCl2, 1 strontium and 2 chlorines, or chlorides. Alternatively, you could do the swap and drop, which means that you take this number and you put it down here. So you swap the number, drop it down to the bottom, take that, swap it down over there. This would give you Sr with the 1 from the chlorine, and the Cl with the 2 from the strontium. As chemists, we don't write 1s. And these numbers on the bottom, they're just the numbers in the ratio of the crystal. They don't actually have charges or anything. They're just numbers. So you drop all the positives and negatives, SrCl2. Next we got calcium phosphate. And phosphate, you would think is just right over here, right? Phosphate, easy. But nope. Chloride, IDE, that's an atom. Phosphate, ATE, that is a weird polyatomic monstrosity. So, calcium, you look it up, it's right here, it's 2+. Ca2+. Phosphate, not phosphide, phosphate, is a monster. PO4, 2-. 3-, my bad, 3-. So I'm going to do swap and drop. If you do it the other way, sorry, 2 is going to go right here, 3 is going to go right there, and you're going to end up with Ca with the 3 from the phosphate, so Ca3, and then whenever we do polyatomics, we put them in parentheses normally. This PO4, I have 2 of them. Now this might confuse you because I have a 3, or I have a 4 and a 2 on the opposite sides of the parentheses. So what does that mean? Basically, PO4 is a big, weird thing that acts just like an atom. So it's like you got a phosphorus, and it's oxygen, 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 oxygen. Phosphorus, 4 oxygens, right? But they're always stuck together. They never, ever are disattached. It's like one human being with 4 heads. So when I say that this is my formula for calcium phosphate, I'm saying that I have 2 monsters with 4 heads. 2 monsters. I don't have 4 monsters. I don't have 8 monsters. 2 4-headed monsters. That's what it means to have this 2 and this 4. Anyway, aluminum carbonate. Aluminum is going to be 3+. Carbonate, you got to look it up on your polyatomic ion sheet or Google it, whatever. It's CO3, and it's 2-. So this is going to go here. This is going to go here. And I'm going to say that the Al now has a 2 on the bottom. The CO3, which is in parentheses because it's one big blob, I got 3 of them. Finally, calcium oxide. So calcium is Ca. It's right here, 2+. Oxygen, so oxide lets us know that it's the actual element, oxygen, right there, 2-. O, 2-. So you swap and you drop, and what you get after you do that is you get Ca2O2. But remember, these aren't actually numbers. It's not like you only have 2 calciums and 2 oxygens. It's a ratio in a crystal, right? And a ratio of 2 to 2 is the same as a ratio of 1 to 1. Or 1 to 1, what am I doing? So you simplify, right? So in this case, calcium oxide is just CaO. Next, it's talking about these numbers. This is just vocab. This little 2, this little 4, this little 3. These are called subscripts. Sub meaning low, script meaning like a word or a letter. So subscripts. And they are not the same. Because this says I have 3 4-headed monsters. This says I have 4 3-headed monsters. Let me draw a picture. Oh man, this didn't go well. Okay, so anyway, this is supposed to be a stick figure, right? With arms like that. And a stick figure with 2 heads would be like this, right? You got that. There's a head. There's a head. My artistic skills are terrible. But this right here, this SO4, you can think of it like having 3 4-headed monsters. So here I have a 4-headed monster, 4-headed monster, 4-headed monster. This is a different kind of thing. I have 4 3-headed monsters. That one, that one, that one, and that one. So even though the numbers are flipped just outside of the parentheses, they're not the same thing because the number in the parentheses tells you what kind of monster you have, what kind of weird combination of atoms, and the outside number tells you how many of them you have. That might not have been helpful, sorry. Next, Lewis dot structures. So N is right. I'll just erase this. Oh, nope. This is normally an eraser. Wait a second. Okay, I don't know what was up with my tablet. So N is right here. The way that you do valence electrons is you count from the right, or from the left to the right, and then you skip these stupid weirdo exceptions. So nitrogen, 1, 2, 3, 4, 5. I got 5. 1, 2, 3, 4. You put 1 dot on every side, and then double it up, 5. Aluminum's right here. It's got 1, 2, 3. Then I get there. So 1, 2, 3, done. Neon is all the way over here. This is neon. So neon has got 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 1 on every side, 5, 6, 7, 8. Like that. Magnesium is right here. It's just got 1, 2. So 1, 2. Carbon is right. Here's carbon right here. This is carbon. So to get there, you start from the left, you go to the right, and you go 1, 2, 3, 4. So 1, 2, 3, 4. Next, I want you to draw the Lewis structure for each ionic compound. So what you got to do for that is you got to draw the Na, 1 dot, Cl with 1, 2, 3, 4, 5, 6. That's how many it has. This goes over. And then when you do that, you have a Na that is positively charged. We kind of get into it brackets like this so that you can see. And then you have a Cl that is now negatively charged because 1, 2, 3, 4, 5, 6, 7, 8. 1 positively charged sodium, 1 negatively charged chlorine. Now the calcium and the oxygen are different because calcium has got 1, 2 dots. The oxygen has 1, 2, 3, 4, 5, 6. So what happens in this case is both of these go over to the oxygen, like that. And so when that happens, you end up with 1 calcium with no electrons, very lonely. It lost both of them. It's 2 plus. And you end up with 1 oxygen with 1, 2, 3, 4, 5, 6, 7, 8. That has gained 2, so 2 minus. Then Ba2. This is a different kind of scenario because barium is right here. It's 2 valence Ba, 1, 2. Then iodine is over here. It's got 7. So iodine's got 1, 2, 3, 4, 5, 6, 7. Now you might notice that when this barium gives this iodine the electron, it still has 1. Like this iodine is done, it has 8, check. But the barium's not done. So it pulls another iodine in from another side. 1, 2, 3, 4, 5, 6, 7. And it grabs the electron from that one. There we go. So in this particular case, what you're going to have is you're going to have 1 barium that has lost 2 electrons, so it'll be 2 plus. You have 1 iodine, which has 8 electrons on it. 2, 3, 4, 5, 6, 7, 8. So we're losing iodide now, minus 1. Then you have another one, because this other iodide showed up. So 1, 2, 3, 4, 5, 6, 7, 8, and it is minus 1. So these are the Lewis structures for the compounds, Lewis dot pushing structures. So complete the table. You got calcium, phosphorus, iodine. You kind of had to do that to do this, didn't you? Calcium's got 2 valence electrons. When you did this, it lost them. When it lost them, it ended up being cation because it lost them, right? So losing electrons is losing negative things. It's like losing your homework or losing your chores. It's good. So negative. So it lost it, so its life is better, so it's cation. Because it lost 2 of them, its charge is plus 2, and its symbol is going to be Ca2+. Phosphorus. We didn't actually do that. Okay, so phosphorus is right here. It's got 5 valence electrons, and it's going to end up being minus 3. So 5 valence electrons. It gains some to get to 8, so that means it's an anion. Its charge is going to be minus 3, and its symbol is P3-. Iodine. We did that right here, right? It's got 7 valence electrons. What happened was it gained 1 from the barium. 7 valence electrons. It gained 1, which makes it an anion because it gained a negative charge. So it only gained 1, so its charge is negative 1, and its symbol is therefore I, negative 1. Finally, write the cation and the anion with a charge for every compound. So remember, cation, positive, it's first. Anion is negative, it's second. Calcium is 2 plus. Wait a second. Figured it might be better if I pulled this down here. So these are all plus 1. These are all plus 2. These are all plus 3. You skip all these weirdos. They make everything annoying. They suck. These are all neutral. Minus 1, minus 2, minus 3. And then we don't really ask you about the charges of these. So calcium is right here. That's why it's 2 plus. Cl, well, that's chlorine right here. It's minus 1. Cl minus 1. This means that I have 2 of them, not that they're 2 plus or anything. So next I got this one, Na2S. Na is right here. So the cation is Na plus 1, sodium, and the S is over here. You can see it's in the column that's all minus 2. S is minus 2. Al2SO4 3. Ooh, okay. So aluminum is right here. This is aluminum. It is in the column that is 3 plus. So the cation is Al3 plus. Now SO4, you can tell by the fact that it's in parentheses, it is a weird monster. It is a polyatomic ion made of a bunch of different atoms stitched together like Frankenstein. Frankenstein's monster, technically, whatever. So you have the SO4, and you have to just look up what it is, right? So you look on your polyatomic ion sheet, and you see that SO4, which is sulfate, is going to be 2 minus. Finally, NaOH. Well, Na is right here. Sodium is a big common thing. So Na is going to be +1. And OH, well, this is 2. This is 2 of them. So they're stuck together. 2 things stuck together is a polyatomic ion. So you look on the back for your polyatomic ions chart, and you see that OH is called hydroxide, and it has a charge of -1. So OH -1. There, hope that was helpful. Sorry it was so long.